Good morning, people. Let us see the inputs for today, sir. I got G Suite login ID, but how to activate the G Suite's accounts? Prathamesh Chavan has a question, and Ami has replied to it, saying that there was a PDF of steps how to log in. There is a link in that. You have to follow those steps. Okay, I'll just throw some more light on that. You may be having your own Google accounts, email accounts. Now you have to create a parallel one. We're using these credentials. Please remember that. So that is an addition to this. Okay, other things, as Ami has said, are there in the PDF which was posted on the group. Mayuri says good morning. Sushil Nishan Rao, good morning. Sanmit, good morning. Karthik, good morning. Avi, good morning. Sandeep, good morning. Ami, good morning. Nisha, good morning. Dhanraj, very good morning. Bhavika, good morning. Sneha, good morning. And Swapnil, good morning. Okay, as I said earlier also that we are in this whole business of transferring from all other platforms to G Suites. And if you remember, I had said that as far as G Suites is concerned, it is a spacious arrangement made by Google. It's a combination of Google Classroom, which is something which has been specially done for teachers, I would say, which involves assignments and other options like tests, MCQ tests, etc., etc. All of us are in a learning process, by the way, let me tell you. So it is not that I would be an expert in that. In fact, some of you all can work on that, and you can post updates with regards that also. And all of this is linked to the meeting app of Google that is called as the Google Meet. Okay, so all of this together becomes Google Suite. I have explained this earlier also, but for those who were not there for that particular lecture, it is for those people. I see 30 people are viewing this. I assume that, however, we are more than 100. The numbers have dropped down, and that is why. That may be one of the reasons why the college is fast shifting to G Suites, because it will give us a detail of who is attending, who is not. If people are logging in, logging out continuously, we'll have a record of that also. So in all that context, let us hope Google would be a good utility, or G Suites would be a good utility for us. Going back to, I'm very sorry I did not go back to the last time's lecture, and thus I'm not able to recollect any of the questions that we had last time. However, I have a very interesting topic for today, and we'll move into that slowly. I'm sharing now. This is where we did last time, and we spoke about how there is a dichotomy between physical and human. And in connection to that, we have a dichotomy between whether geography should be studied systematically. Here, I would remind you that systematically here does not mean the real sense of the dictionary meaning of the word systematic. It is rather a process of research or studies followed in geography, wherein we take a particular system, a river system, a mountain system, a transport system, an agriculture system, studying it in that particular way. Or as against that, some geographers follow what is called as a regional approach, wherein you take a region and then you study all the points within that. Okay, so that was another dichotomy. Deterministic and possibilistic, where determinists believe that nature is supreme and it controls a lot of things around us, or rather, I would say, controls all the things around us. Possibilists go on to think that though nature tends to be supreme. Man has the brain and he has the skill to, and of course now he has the technology also to overcome all the restrictions and obstacles that nature poses us with. And we went into these various phases of learning geography. What is the viewpoint? Okay, how do we look at it? It, in other words, means the theme. Okay, we go by place, we go by space, and we go by scale. And then how do we synthesize? We synthesize it in three levels: the human geography level, the physical geography level, and of course the border between these two, that's the human physical interaction. And how do we represent it? We represent it by cognition. We represent it through models of mathematics and statistics. We tend to describe, okay, what we see in front of us. And of course, we use visual display as well in the form of diagrams, etc. And of late, the latest entrant into all this is GIS, which is digital mapping. And in fact, it is not just mapping, it's in fact an interactive software which will help you to answer questions, provided of course it's more a statistical software, I would say. Thus you'll see that when we ask questions in a particular software in GIS, we have to remember that the questions need to be say in connection with the basic parameters on which that particular software has been derived, because the parameters need to be solid. Okay, because if you're seeking an answer for something which could be risky over the period of time, you should be very careful of what parameters you are using in the software to get a question, get an answer out of it. Say for example, the other day, location of a ski resort is what we said. You'll see that one mistake here and there could be very risky, so we have to be very careful as far as designing a program as far as GIS is concerned. Then uh, this is what I have been longing to speak to you about. It's not a part of your syllabus, but we intentionally, okay, in Marathi medium as well as the English medium, we intentionally introduce this basically because geography cannot be learned unless and until you know this thing that is in front of you. This is called as the geological time scale. uh, you'll see that we have different types of time scale, isn't it? You have a watch, and it is on the watch that the scale is 1 minute. The least count is 1 second. The least count here is not microseconds, but you go to run 100 meters race, and the least count there is going to be microseconds. They divide a second into 100 parts because they need to know who is actually the fastest when it comes to the world championships as far as 100-meter races, a race or a sprint is concerned. So the scales differ. Okay, they differ on the need. Okay, see, microseconds is the need for 100-meter dash. Okay, but microsecond is not a need for my day-to-day activities. Okay, you will see that as far as a budget is concerned, for them the least count is months, and of course other economic activities. You'll see that say for income tax, for example, their least counts are going to be different. Similarly, when we come to geography, particularly the physical part of geography, where we are speaking about the Earth, and on the Earth we have new objects as well as old objects. But when we say we have new landforms, these landforms are not in the sense of new in the sense of new cloth, etc., that we would be wearing on Diwali day. Okay, when we say new, it already is a few thousands, a few 100,000 years old. And when I say old in the geographical sense, it is literally very, 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 very old, because it runs into millions and hundreds of millions of years as such. So, and here, something that we did at an earlier point is going to be very interesting and important as to how we understand these numbers of millions and billions and crores and lakhs. Of course, we are not going to speak immediately on lakhs and crores, but remember that as far as the international configuration, the multiples of three zeros, the first three zeros, okay, is thousands. The next three zeros, that's six zeros together, is millions. Another three zeros is billions, and another three zeros, that's 12 zeros, would make it trillions as such. However, as far as measuring the age of the Earth is concerned, it has been a hell lot of a job for scientists from different fields, and you'll see that even today we are still not uh, so to say, very assured about the age of the Earth. But given the efforts, the technological efforts that we have put in all together, it may be sound to say that whatever numbers we have for the day are significantly correct. But having said this, there is another aspect to that wherein it was believed a few hundred years ago that yes, that's the ultimate as far as the age of the Earth is concerned. And you'll see that you have different writings on the net, and you've different books and other things as such, and that makes this very much interesting. And that is why I had to refer to two sources. In fact, one of the source is a textbook in geomorphology written by P. Dayal. He was the former vice chancellor of the Patna University. He's an excellent writer in uh, geomorphology, and many geography students and teachers do follow his write-ups as far as geomorphology is concerned. The reason being that I believe he's one of those Indian geomorphologists whose writings Indians can easily understand, and in has written in detail, and he has used a lot of Indian examples, so you appreciate that as well. That's one source that I have used, and the other source is a documentary that I have with me, which was screened on the History Channel. This documentary was made by the BBC for the History Channel. And in fact, normally when we are on campus, when I'm doing this with you all, what I do is I screen that for the students in the class as well. Unfortunately, now today we are at our own places, and I would not be able to. I'll see the possibilities wherein we can sit together in the sense on the internet, and being say comfortably socially distanced, we can go through that, because just watching that is not going to be say enough for the understanding the whole process. And that is why I always give a give a commentary on what is happening as far as that particular documentary is concerned. So I'm checking. Otherwise, I could have just uploaded it on my Google Drive and have had given you all the link, and you could have gone through that particular screening as such. But it's a bit difficult to understand towards a particular part. So and at times it gets a bit academic, so I wanted to just correlate to that. Let us see how we can work it out. That's These are the two, I would say, references that I am going to use as far as the lecture is concerned. I don't know whether I would be finishing this lecture in today's thing as such. And that is why another thing that I wanted to tell you all is tomorrow we are conducting a backlog exam for the science students, practical exam. We are starting early, and I would try to be free by 10 o'clock. So there is a bit of unconformity as far as whether we would be having a lectures. If you remember, I did say that we are in November already, and now we need to continue with our regular share of lectures. That's 3 lectures in a week. That's Thursday, Friday, and Saturday. So having said that, it would be nice to have to start the Friday lectures as well. In an extreme case, if I'm not able to make it up, we could start a bit delayed. The start could be a bit delayed as such. I would be keeping you informed about it on the group tomorrow. But if you speak about percentages, I would say 90% chance is there that we would be conducting our lecture tomorrow. 95% that we would be, 97%, let us say, that we would be, the above 7% is going to be with, we would be delaying it a bit. And there's only 3% chance that we would not be conducting tomorrow's lecture. So this is it. Now, before you go into the details, I don't know how many of you all have already started reading into the slide in front of you. Um, Before we go into that, okay, a man has always been curious about what is the age of the Earth. Okay, right from say, and man is a curious animal. You'll see that Eratosthenes was curious enough to basically think about whether the Earth is spherical, and if the Earth is spherical, what would be the length of the circumference, the total length of the circumference, and how close he came to that by using the geometry of it, the basics of geometry as such. And right from that to the point wherein the whole world went into what is called as the dark ages, to such an extent that we forgot that it was 2000 years ago that people had already said that the earth is spherical. And in fact, the 15th century, 16th century, 17th century we came to a point that we did not believe that the earth is round. And that is why there needs to be a connection into say research into uh, academics and so on and so forth, so that you keep on advancing and you don't have to start again. However, when people started studying about so to say the studies into how to calculate the age of the earth as such, it is very interesting to note that uh, people started with very mere numbers. Now, how did it's not like you put your hand in a lottery pot and you pull out a chit and you say that, okay, the chit says that the earth is 2000 years old, and everybody announces that the earth is 2000 years old. Different methods were used by different scientists as far as measuring the earth's age is concerned. They were very curious of going into that. But as far as the present age is concerned, we did discuss about this earlier also, that the present age of the Earth is 4.6 billion years. And this age has been estimated by a maverick scientist called by the name James Hutton. We're going to come back and visit to Hutton basically because it was way back in 1788 that Hutton, somewhere in, he was placed in Scotland. He was basically a farmer, and rocks interested him a lot, and later on he went into details of understanding rocks, etc. And that is how we came to understand that the earth is much much older than what his predecessors had underlined. Now, what had his predecessors done? They had used various techniques, say for example sedimentation. What does sedimentation mean? You'll see that if you see a river, the river brings in its material and it sediments. Okay, so you study as to how many millimeters of sand is sedimented at a particular point in the course of a particular river. And if you say that it's zero point 0.1 millimeter per year, then if you have a rock which has come up in sedimentary rock in the basin of that particular river, which could be 2 meters thick, you can just multiply and identify what could be the time taken for that particular sedimentation, and you could say that, okay, the river has been working for so long, so possibly the age is this. But then they missed out on one particular aspect, that what if the river itself is new, it is not very very old. So that's a very interesting question, and here is where people lost the hooks. So they said, okay, if the rivers are not giving us the age, at least the oceans have been there for a significant period of time. So can we use some parameter in the ocean to measure the age of the earth? And that parameter was salinity. We know that as far as this salinity is concerned, the salts tend to come from the rocks that the rivers erode, and it is this rock, this salt that tends, these various salts, sodium and potassium and chlorine and so on and so forth. Okay, they keep on to be getting added to the oceans, and if the percentage of salinity increases by a particular number in 5 years, in 10 years, what could be the total amount of years that these salts have been coming into the ocean? And thus you could just go into measuring the age of the earth. But then another question mark for this is that this only starts working when you have enough amount of water. What about the phase when you did not have water on this particular planet, whether there was a stage like this? So this question mark again went into difficulty, and then people started looking for new options as far as what could be another way in which we could measure the age of the earth. Then came in fossils. Okay, you'll see that sedimentary rocks had a lot of fossils, and the scientists started studying, geologists, geographers started studying these fossils, and accordingly, the age of these fossils, according to the age of these fossils, they tended to give the names, give the age. Okay, but then again the question still remained as to what about the period wherein life was not that large size to be uh, say trapped in rocks as far as fossils are concerned. So there was always a question mark as far as these aspects are concerned. So uh, scientists started looking for a new type of method, and they came up with what was to be called as the rate of cooling, because it is believed that initially the earth was on nothing but a ball of molten mass, and it has been cooling gradually, and they started using laws of physics and chemistry, and started measuring what could possibly be the age of the earth. So from sedimentation to salinity to fossils, dating of fossils, carbon dating as it is called, and the rate of the cooling of the planet itself altogether were different methods which were used. And in fact, some scientists also tried to use what is called as um, say the tidal force of the moon on the earth as such also. So that was a very interesting thing. And by the way, I would like to just enlarge this a bit, and you can go into you can just go into the details of what you can see in front of you till I narrate all this. I What I was looking for was an interesting and a funny aspect that I need to share with you all. No issues. I will come to that. Yeah, I have it in front of me. In fact, you'll see that those who are students of history and who have been studying European history as such, we know that the church was very dominant, and while scientists and all these studies, by the way, are 18th, 19th, and of course the 20th century. Before that, we know that the church had a very strong hold on the people in Europe, and in fact, people tended to believe everything that the church said, and the church has had its say on the date of the earth or the age of the earth also. Okay, the church had said, declared then, and of course this is there in the documentary named How the Earth Was Made by the BBC, and it's from there that I have picked it up that the Earth is 6,000 years old, and in fact, the church went ahead to church in the sense people in that particular the prime church, Vatican, or like what we have Vatican today. They even declared the date and the time on which the Earth went into formation. They said that it was 14th of October, and it was the afternoon of the 14th of October, 6,000 years ago, that the earth went into formation. Of course, what was to happen later was to completely set aside all these foolishness, and we went into greater amount of preciseness, okay, as far as possible. What I want to, by the way, what I want you all to search here is, I'll just tell you that towards the left hand side, the numbers are millions of years ago. Okay, so 600 million of years ago is the base of your slide, and from there you come towards the present era, and the then you have the eras, the Proterozoic, the Paleozoic, if you can read, and then you have the periods, and of course then you have the epochs. But then towards the right side, the pictures of these animals is basically the animals which evolved during that particular period of time. Okay, you'll see that it's a very interesting story, and that's why and it's very important to know this basically because it helps us to link our studies, not only geography, other studies, to a lot of things that are happening around us. So you'll see that these scientific studies to go into the study of the age of the Earth started with towards the end of the 19th century. It was in 1897, to be more precise, that John Jolly, okay, we will be hearing his name further in geography also, John Jolly. He calculated the age. He calculated the age of the Earth to be 90 million. So here it starts. You'll see that the church says that it's 6,000 years old, but scientists knew that it's not that short a period. It's going to be not in thousands and not in lakhs. It's going to be millions. And so 1897, Jolly comes up with a figure that the age of the earth is 90 million years, or the earth is 90 million years old. uh, then we come to another stage wherein a few years after that, a few years say around 1900s, Kelvin comes up with a figure which he says is it's not 90 million, it's 100 million years old. Now, when people asked him, how do you say it is 100 million years old? He says that, look, we all confirm to the fact that the earth has a volcanic origin, right? And in fact, it had a very high temperatures at the start of its age. So if we say that in the initial phase, the earth was a molten mass, all you have to do is you have to calculate the rate at which the earth will cool. And given the present circumstances that you have very high temperatures towards the center of the earth, while on the surface of the earth, okay, that's the crust, the temperatures are as good as normal temperatures. All we have to do is have to calculate the rate of cooling, and applying this physics or the laws of physics and chemistry, we can come up with the time that has taken for cooling all these crustal masses, okay, the crust and the mantle and so on and so forth. And it's very simple. He said that you calculate this, and this gives me the number of 100 million years, or that the earth is 100 million years old. However, scientists were not convinced, and you'll see that within 4 years of time, 1904, uh, you will recollect that this is a period wherein a lot of radioactivity research was going on, and it was in 1904 that Rutherford, who discovered radioactive radiations, he spoke that as far as counting the age of the earth is concerned, and as far as the surface temperatures and the core temperatures are concerned, it is not only to do with so to say the cooling, because there is one more aspect in the interior of the earth which keeps the temperatures warm, and he said that is radioactive material, uranium, for example. You'll see that it is these radioactive materials that in their process of going into the process of half-life period, etc., they are, say for example, uranium decays into lead. So studying the amount of lead, and that, okay, that uranium has transferred itself into lead, he calculated and put all these calculations, and he said that it is not 100 million years, it is much more than that. And in fact, as far as Rutherford was concerned, he convinced people to quite an extent that it's much more than what Kelvin was saying, Lord Kelvin, in fact, was saying. But another, say, 6-8 years went by, and 1911, there comes a geographer by the name Arthur Holmes, and we have a complete theory of crustal evolution behind him. He speaks about the fact that it's not to do with only the cooling, it's not to do only with the radioactive things, but then it is to do with something which is called as convectional currents. And in fact, his theory is also called as the theory of convectional currents as such. He says that as far as these convectional currents are there, they are set up by radioactive material, and it is that the warmer part, say the warmer material, gets lighter and it comes up, and then as it comes up, it cools down, and then it is displaced by the next upwelling current of convection, and thus you have convectional cells which are developed. And as per his calculations, he says that given these convectional cycles, etc., it is not millions that we need to be content with as far as the age of the earth is concerned. It is in fact billions. And in fact, it was for the first time that scientists now started saying that the age of the earth is in billions of years rather than in multiple millions as such. However, after that, the age of the earth started getting older and older, from 1 billion, possibly they said, no, it's not enough, 1 billion, 2 billion. Until around 1950, you'll see that we as human beings believe that the earth is 3,000 million years or 3 billion years old. It's only of late, the last 3, 4, 5 decades as such, that we have confirmed for present, we have confirmed the age of the Earth to be 4.6 billion years as such. Now, this 4.6 billion years of age, as far as the Earth is concerned, needs to be subdivided. Now, how does this subdivision take place? It is, let me remind you that this division is not at all based on a geometric division. That okay, 5 billion, so I will say distribute it in 5 parts of 1 billion each, and then the 1 billion is divided into 10 parts of 100 million each, and so on and so forth. It's not a geometric or a mathematical division. These divisions are based on some striking discoveries that came up with the use of technology at that particular point of time. And that is why you'll see that it's very interesting to see how the scientists went to set up the whole scale of the geological time scale as such. Now, on a very broad scale, okay, very broad scale, the geological time scale is divided into what are called as eras. Now, I will just get you to that. Now, as far as these eras are concerned, you'll see that let me just enlarge this for you. You'll see that you can see your chronometric eons, then you have the eons. I'm referring to these eras. Okay, we'll not go into these details, but we'll go into these eras, and you'll see that the eras eventually will be divided into periods here. Okay, and it is these periods which will eventually be divided into epochs. Now, what these are and how they are interested, how they would be interesting us, is very intriguing, and let us go into the details of that. Now, you'll see that if you are able to see these numbers on your screen, the oldest they have written here is 4,600 million years. So 4.6 billion years ago it starts. However, you'll see that it is quite blank till it comes to 500 million years. Okay, in fact, we can say it is nearly 600 million years. And it's very interesting that when scientists are speaking about these years, they say that we could be wrong by say 10 million years here and there. Now, let me tell you, 10 million years is a huge time. Man has not been there on this planet that long. In fact, man is only 5 million years old on this. Okay, so that's a very funny statement when the researchers say that we could go wrong by 5 million, 10 million years here and there. Anyway, so you'll see that these are era, and of course you can see that the magnitude, the scale, as I said, it is not the same. We need to go into a bit of logics as to how these names come and so on and so forth. You'll see that this red thing here, this red column here, this has been named as Precambrian. What is Precambrian? Okay, now remember the prefix is pre. Okay, the word is Cambrian. So obviously there needs to be a word Cambrian somewhere, and the period before that is called as Precambrian. I know this is going to be a bit technical, but if you follow me well, I'm trying to make it as interesting as possible. Even if you don't remember all the words, it hardly matters now, but you can go back and revise on all these things. Okay, now if you have seen things which I showed you earlier here, okay, here is the word Cambrian, isn't it? So the period before this, and if you see, it's 550 here. Okay, 550, 600 million years, and this 550 is here. So the period before Cambrian period here is called as the Precambrian. But you'll see that a significant amount of it is blank. It's blank because we don't have much details. Now, there could be various reasons we don't have these details. Because most of these records after the Precambrian period is based on fossil dating, the radiometric dating or carbon dating of fossils. Now, there were hardly any fossils, or there are hardly any fossils that are found which are as old as 600 million years. And that is why you'll see that that column is significantly black. So before that, what happens is all you have is rocks. You have to go into rock dating of these rocks, and we try to analyze them and period. However, the pre-Cambrian period, you'll see that it is divided into the Prisconian age, for Prisconian eon, and then you have the Archean and the Proterozoic. Now, this period, the first few millions of years as far as the Earth is concerned, this is say around half a billion years. Okay, so it is running from 4,600 to 4,000 million years ago. So million years ago. So that is when the Earth was very molten. Okay, everything was in a liquid format. Then you did not have rocks, and all the rocks which were there, in fact, were in the form of lava, and thus it's very difficult to find dating of that particular period. But you find rocks after that, and these very old rocks are called as the Archean rocks. Archean rocks. Now the name is equivalent in Indian terms, and I will come to that. Let us try and first understand this whole table. Once you have understood that, we'll go into the geography of that, and we'll go to the other aspects, the life aspects of that, and so on and so forth. And then you have the period between 2,500 million years ago to around 500 million years ago. So that's a period of around 2 billion years, which is called as the Proterozoic. Now, let us come to understanding the logic of how these names are. What are these names? Okay, you'll see that Zoic, Z-O-I-C, Zoic basically means life. Okay, life. And that is why when you say, when we'll go into the details here, let me now enlarge it for you. Okay, you'll have Paleozoic, Mesozoic, Cenozoic, and you have Proterozoic. Okay, Proterozoic. Proterozoic it means that life was emerging on that. Pro means towards life. Pro means towards life. You're going towards life. You have microorganisms and single cell and multiple cells. Of course, not large enough still, but there is a definite signature that you are going to have life in, say, possibly a few billion years from now. And then is when you come to what is called as the Phanerozoic eon. Phanerozoic is basically larger form of life. Now, what does this mean? Okay, this period is divided into three eras. The last 600 million years are divided into three eras: the Paleozoic, the Mesozoic, and of course the Cenozoic as well. Now, what is this? Paleo means paleo. Paleo studies means very old studies. So when I say Paleozoic, you can note this down somewhere. When I say Paleozoic, it is the old form of life, very old form of life. And what is this old form of life? The first picture that I showed you, okay, that's an old form of life. Okay, okay. Let me fetch the. Okay, you'll see that these animals are very peculiar here. Okay, during these. Okay, all this is Paleozoic. You'll see, you can read it here. This is Paleozoic. Okay, very queer animals. You'll see that not similar to the animals that you would find today. Okay, and that is why these are called as older forms of animals. That's Paleozoic as such. You'll see that it's the first type of skeletal animals, soft bodies, metazoans, first animal traces. Okay, all this is happening towards late Proterozoic, and then you come to Cambrian, wherein you start having the first types of fish, or the choroidates. Choroidates is basically those who have the vertebral column and so on and so forth. Okay, so this and then you have the other animals, and then the others. Okay, you'll see that you have first vascular land animals, and then we have somewhere here in the Carboniferous period, you will have seed ferns, and you have scale trees, and of course you start having the first reptiles also. So this is how evolution has taken us. Okay, but going back to what we were into, that Paleozoic, Mesozoic, and Cenozoic. Okay, the old form of life, the middle or median form of life, and Mesozoic. By the way, you can remember it very easily. All these Jurassic movies, okay, dinosaurs, okay, existed between the Mesozoic period. So Mesozoic coincides with the dinosaur period. Okay, now why the animals went so large? We have a logic for that. And then you'll see that you have the Cenozoic, which is the most recent of the periods. Modern life and mammals, us human beings and all other animals belong to this particular period. Okay, mammals were not there in the Paleozoic or the Mesozoic. Okay, or towards the or later part of the Mesozoic, we had very small type of mammals. Now you have very large mammals. You'll see that the largest mammal on land is the elephant, and the largest animal, in fact, on this planet is a mammal, and that's the whale. So that's an interesting thing that we have to keep in mind, that mammals started from a very small average size to now we have come to a larger average size. Then you'll see that all this fits into 500 or 600 million years. Now, why I am saying 600? Basically, because we agree to a fact that the age of the Earth is 4.6 billion years. Okay, so that 6.6 is 600 million, and that has been divided into these eras. Okay, now actually an easier way, it's not a technical way of doing it, but to remember how this is divided, it's approximately that as far as these Paleozoic era is concerned, it accounts for half of the 600 million years. Okay, so that leaves around 250 million years for y'all. And then again, a two-third of the remaining is used up by Mesozoic, leaving only around 60 to 70 million years as far as the Cenozoic period is concerned, or modern life period is concerned. So the Paleozoic, the Mesozoic, and the Cenozoic. Zoic is life, Paleo means old type of life, Meso means moderate type of life, meaning reptiles here, and you have Cenozoic, that is modern type of life as such. Now you'll see that the second column is basically an expansion of that. And what is that expansion? Let us see. Okay, you'll see that here, okay, the 600 million years, etc., that we say, the oldest of this is Cambrian. So when we are speaking about this Cambrian, or rather pre-Cambrian, this is all that period before to this. And let me say that while Paleozoic is the last or the oldest of the, so to say, um, oldest era, okay, Cambrian is oldest of the Paleozoic. And you have these stages, okay, and you'll see that the scaling is not equal. Some of them are longer, some of them are shorter. Okay, then you have the Cambrian followed by the Ordovician, then you have the Silurian, then you have the Devonian, then you have the Carboniferous, and then you have the Permian. Okay, these are called as periods. Okay, there are 7 periods in the Paleozoic, there are 3 periods in the Mesozoic. 7 in the Paleozoic, 3 periods in the Mesozoic. That leaves 2 periods in the Cenozoic. Now, again, there is a debate about what these 2 periods are, or whether we should be calling them as periods or them as eras. We'll come to that later. But you'll see that it is these periods, the latter part particularly, is divided into what are called as epochs. Okay, now let us see what these epochs mean. Okay, you see that what they have done is this part, the tertiary part, has been again zoomed in. From this part, they zoomed into the second column. The second column zooms into the third column. The top of the first column forms the second column. The top of the second column forms the third column, is how you remember. Okay, the period, you'll see that it's tertiary period. And the epochs, you'll see, is they are further divided as such. Okay, you have quaternary written here. Okay, you have quaternary written here. The tertiary is longer period of that. Quaternary is the most recent time. The last glacial, or rather ice age, that we have is had during the quaternary period. And then you have Holocene. If you can read here, Holocene, the most recent is when man arrives on this planet. So comparatively, and in fact, I have a very interesting comparison for that, and we'll be coming to that when we speak about man, how recent has man been on this particular planet as such. So what this geological time scale means, I'll just again read it out to you so that you can understand it. Okay, you'll see that the first column is the age, the whole age of the earth, and you have these representations on internet. You go to Google and search for geological time scale. You have various representations of the geological time scale. So the first column is all the 4.6 billion years. That's the age of the earth. Okay, the second is the 0.6 billion years. of it. And then the third is the last, the tertiary period, which includes, sorry, the Cenozoic, the modern life, which is the 60 or say 65 million years. Okay. Um, that is how this is divided. Now, I would not stress your minds, but I don't know whether anyone of you all has read through this. Camels often sit down carefully. Perhaps their joints creak persistently. Early oiling might prevent permanent rheumatism. Now, I don't know why this term is there, or this sentence is there here along with this. If any one of you can make any sense out of this and help me with that, it would be fantastic. Anyway, coming back to some aspects here, okay, you'll see that if we go into go from the modern period. Now we had come, the left side diagram, we came from the older earth to the modern earth. Now let us see if we can go back from the modern earth to the older earth. You'll see that quaternary period, this period here, the most recent one, is where you have had humans, evolution of human beings. And you can see this is a man walking on two legs, bipedal motion as it is called. We spoke about it a few lectures ago as well. And then you'll see that as far as the Cenozoic period is concerned, you'll see that before that, what happened before man came up, you had mammals who diversified into various animals. Okay, and then this is as far as the Cenozoic period is concerned. Before that, you have the Mesozoic period, and the whole of the Mesozoic period, the Triassic, the Jurassic, and the Cretaceous. Okay, you'll see you have the first dinosaurs, you have the first mammals, then you have the dinosaurs diversifying, then you have the first birds who fly as well. Then towards the latter part of the Mesozoic, you have flowering plants. Flowering plants is a typical type of reproduction, which marks a typical type of reproduction in botany. And then you have first primates. Now, why they written first primates here? Basically, because human beings have evolved out of these primates. So it is from here that the initial thrust started. However, it took a few million years before it reaches to the present status as such. So this is how the animal life has been increasing. We'll try to go a bit more into the older part as such. Okay, you'll see that Jurassic, Triassic, Permian, Triassic, and before that, that's the Paleozoic. You have very different type of animals here also. You'll see that first reptiles, in fact, start occurring towards these periods as such. Okay, you'll see that fish having jaws. Okay, so possibly the fish before that did not have jaws. So it's in the Devonian period that you find fish having jaws as such. And then you have the first amphibians. Amphibians is basically animals who can live on land as well as water. So you'll see that till the Devonian period of the Paleozoic era, most of the life was concentrated in the ocean waters. It's during the later part of the Devonian period that life starts to shift from water onto land. Now, why was life not shifting is one question that I would ask you all. That why did we not have life on land? Why did we have life in water much before we had life on land as such? I think we have used up a lot of time for the day. However, we have possibly covered only 40% of the whole story about the geological time scale. Okay, I'm leaving you with these two questions as to why did it take late as far as the Devonian period for life to come on to the land, and what does this make any sense? Camels often sit down carefully. Perhaps their joints creak persistently. Early oiling might prevent permanent rheumatism. Um, I can't think of any sensible explanation to this. Let us think about it, and when we meet back tomorrow, uh, there are some questions. Okay, now Sandeep Mule says that today's YouTube lecture you said picture of glacier and penguins. Any reason? Well, no specific reason as such. It's just to make the cover page or the thumbnail interesting. Uh, you can relate it to climate change and the concern that we should be having. Then the Nupur is saying something that sir slide blur आहे काहीच कळत नाही सर प्लीज स्लाइड क्लिअर करता येईल का I don't know now whether this has persisted to be a problem, but or over the period of time it has cleared off. I would like more comments on whether you have been able to see it or not. I have tried to put up the best picture, but in case it has you have not been able to see a clear picture, I'm very sorry about that. But as I said, you can go to Google and search for your own uh, picture of the geological time scale. And in fact, if you study that the picture of the geological time scale by yourself, it would make very you could relate to a lot many things in geography and other subjects also. Ami says that because life started from water. Yes, I say life started from water, but then why didn't it start equally on land and water? Is what was what my question was supposed to be. If both of them are spheres of life, we have been discussing about it, and in fact today you'll see that majority of the life is on land. In fact, man, we are studying all these things and we are land animals. So why is it that an intelligent animal like a man did not come up from the water? In fact, it had life had to shift to land, and once life had shifted to land, it had to evolve, and we have mammals, and then all through the way of the climbing ladders of mammals, we eventually come to human life as such. What could be the possible reason? There are very interesting things to be learned about this. However, given the time that we have used for the lecture today, we would have to stop here. And tomorrow, when we meet, as I said, I would make 90% of an attempt to conduct the lecture tomorrow at 10 o'clock. Details, of course, will come tomorrow itself. We'll continue with how we understand the whole thing. By the time you try to think and search and read pictures on the geological time scale, try to understand the words that are there as far as these geological time scales are concerned. And if you take pictorial ones, don't take, and that's why I have purposely kept one pictorial one to the right side and the text one to the left. If you just look into text ones, it tends to be a bit boring, but if you look into the pictorial ones, it tends to get very interesting. And in fact, I would appreciate if you look for such pictorial ones and you post them in our group for other students to understand from them also. So we'll stop here today, and tomorrow we'll continue as to how life evolves, why did life evolve, and what has the whole story of camels and their knees and their joints aching, to whether there is any connection between all those camels and their joints aching to the geological time scale. If anyone finds an answer, please let me know about it. Thank you very much. I am ending my lecture right now, hoping to